Imagine you are at a party. Someone drops ice into your drink, and you notice something curious. The ice cubes from the bag at the store look like crystal glassy, almost invisible in the water, while the ones you make at home in your freezer are white and cloudy at the center, like frosted glass. Both are made of the same ingredient, just frozen water. So why do they look so different? The answer begins with the way ice freezes. When you pour water into a tray at home and slide it into the freezer, the cold air surrounds the tray. The water begins to solidify from all directions, at once the top, the bottom, the sides. That creates a shell of ice enclosing the liquid interior. As freezing continues, the last water trapped inside has nowhere to go. It holds dissolved gases, tiny air bubbles, and trace minerals from your tap. Those get forced into the center and locked in. When the final pocket freezes, the trapped air and impurities scatter light, creating that cloudy white heart we're so familiar with. Now, imagine doing the process differently. Industrial ice makers, the kind that produce those beautiful clear cubes at bars or in bags, freeze water in layers, usually from one direction only. Often, they have a cold plate or coils at the bottom, and water constantly flows over them. As the water touches the cold surface, it freezes upward in thin sheets, while the flowing liquid above carries away dissolved air and impurities. This directional freezing pushes imperfections out of the forming ice, instead of trapping them inside. By the time the cube is fully formed, what remains is solid, uniform crystal transparent ice, with nothing to scatter the light. This difference explains more than just aesthetics. That cloudy stress at the center of homemade ice is why your cubes sometimes pop or crack when you drop them in a drink. As the air bubbles trapped inside expand, the internal fractures snap, and the cube splits with a satisfying little explosion. Clear ice, by contrast, holds together more smoothly because it has fewer internal stresses. Bartenders and cocktail enthusiasts value it not just because it looks elegant in a glass, but also because it melts more slowly, with no weak spots full of bubbles. It stays solid longer, keeping drinks cold without watering them down too quickly. There are other factors too. Water itself holds dissolved gases, mostly oxygen and nitrogen, picked up from the air. Cold tap water holds more gas than boiled water. That is why some people suggest boiling water before freezing it to get clearer cubes. Boiling drives off much of the dissolved air, so fewer bubbles form during freezing. Others use distilled water, which lacks the minerals in tap water that can crystallize into tiny imperfections. But even boiled or distilled water frozen in a home tray usually turns cloudy, because the real culprit is the way the freezing happens from the outside in, all at once. Commercial machines solve this by directional freezing. But you don't need an expensive appliance to try it yourself. Cocktail hobbyists have learned that you can mimic the effect with a small cooler in your freezer. Fill it with water, leave the top open, and let it freeze for about a day. Because the cooler insulates the sides and bottom, the water freezes slowly from the top down. Impurities and bubbles get pushed downward. And if you remove the block before it finishes, you can cut away the cloudy layer at the bottom, leaving a slab of perfectly clear ice to shape into cubes or spheres. With nothing more than a bread knife and a hammer, you can make your drinks look like they came from a high-end bar. Sports arenas use the same trick on a larger scale. In hockey rinks or curling sheets, Workers don't just dump water and let it freeze. They spray thin layers over refrigeration coils, freezing from the bottom upward. Logos and colored lines are painted on the ice between layers, which is why they remain visible through the clear surface. No matter how often the Zamboni scrapes the rink, the clarity of that ice comes from the same principle. Directional freezing allows gases to escape, leaving a transparent sheet sturdy enough for skates and stones. The cloudiness of ice is not stress alone. Those stress fractures can add to the frosted look. At its heart, cloudy ice is about trapped air. When the water shell forms too quickly around liquid, the gases dissolved inside have nowhere to escape. The result is a miniature snow globe of bubbles. Industrial clear ice machines, with their flowing water systems and cold plates, are designed specifically to let those gases leave before the cube is complete. In other words, cloudy ice is water that froze before it had a chance to breathe. Even in nature, you can see the same effect on that calm winter lake, where ice forms gradually from the surface downward. You sometimes see sheets as clear as glass, thick enough to walk on, revealing fish swimming beneath your feet. In contrast, shallow puddles that freeze rapidly overnight trap air and debris in a frosty lattice, looking white and opaque. The difference is always about speed, direction, and the chance for impurities to escape. Some people experiment with other tricks, freezing water twice, allowing it to freeze, thaw, and freeze again can reduce cloudiness by letting gases escape in the first round. Some boil water multiple times, then seal it to prevent new gases from dissolving before freezing. Others invest in high-end clear ice machines, where water circulates continuously until flawless blocks emerge. No matter the method, the goal is the same: to control the direction and pace of freezing so that nothing gets trapped inside. There is something poetic in the idea that clear ice is simply patient ice. Cloudy cubes are rushed, frozen from all sides, holding on to every bubble and impurity. Clear cubes are deliberate, frozen layer by layer, allowed to shed their imperfections as they grow. It explains why they glisten like crystal in a drink, refracting light instead of scattering it. They are, quite literally, ice without secrets. So the next time you notice the difference between store-bought ice and the cloudy cubes in your freezer, remember that the secret is not the water itself, but the journey it takes to become solid. At home, the cold rushes in from all directions, trapping bubbles in the heart of each cube. In factories and bars, freezing happens slowly, directionally, sweeping those bubbles away. What looks like a small difference in method transforms the appearance and quality of the result, and perhaps that's why clear ice fascinates us. It turns something ordinary into something elegant. A reminder that even water can become beautiful when given the right conditions. A cloudy cube carries the memory of its rushed birth. A clear one carries the patience of its careful making. In your glass, the difference is striking, and behind it lies a story of physics, chemistry, and the quiet art of freezing.